All right, here we go. The last example for this is going to be our longest example. We're going to do circles and ellipses. And so we're going to start with an easier interval, and then we're going to work to a harder interval. Okay, and so what we first have to do is you're going to do two things. You're going to write the rectangular equation. And then you're going to head and graph. Okay, so you gotta write the rectangular equation and graph. There's one thing I forgot to put in the review section, I don't know why. One other key fact you do need to remember, okay, is, so we have x is equal to r cosine of t, y is equal to r sine of t, and we know that sine squared of theta, I'm gonna do t, plus cosine squared of t is equal to, hopefully I answered it correctly, 1 equals 1. Okay, sine squared plus cosine squared equals 1. So those are the three equations we're going to use. If you do not have a unit circle, go ahead, pause, go get your unit circle. Where did I put mine? I literally just got it. If you haven't, you lost yours, threw it out, whatever, go ahead, print out the blank one, fill it out, that kind of stuff. You will need one. Not completely, but you'll want to have it for reference, unless you have your whole unit circle memorized in your head. Then good for you. Okay, so this first problem that we're going to do is we have x equals -5 cosine of t. I have y equals -5 sine of t, okay? And we are going to be on the interval from 0 to 2 pi. I'm gonna put the second problem up because there's one key thing I want to talk about that we talked about at the very end of our last lesson. Okay. So these would be the two problems we're going to do, or we're going to do 4 of them, but these are the first 2. Okay, and so what I want to talk about is the very slight difference in this. One of the ones most of you would probably notice is, oh, cosine's with x here and sine is with y here. Okay, is that a problem? No. Okay, if cosine's with y or x, it doesn't matter. What I really want you to be able to tell is we're doing circles and ellipses. So hopefully, as you did that last topic, telling the difference, you notice circles always had the same leading coefficient and ellipses didn't. Okay, so right off the bat, we can tell right now this is a circle because it's both -5 and -5. And this is going to be an ellipse because it's -4 and -2. So hopefully that is going to ring a bell for you or anything like that, okay? So just knowing right off the bat what you're dealing with. So we're going to do the circle one first, okay? So we got -5 cosine of t and y equals -5 sine of t. So what we really want to plug this into is this big mess. This is going to be our favorite thing to plug it. Oops, sorry. Sine squared plus cosine squared equals 1. We want to plug it into that. Okay, and so what that means is I need to go ahead and solve for sine and cosine. All right, so this would be, I'm going to use a different pen so you see my work. Okay, so we have x over -5 equals the cosine of t, and y over -5 equals the sine of t. Okay, and so I'm going to go ahead and plug that in there. And so sine squared is going to be y over -5 squared plus x over -5 squared equals 1. So I have y squared over 25 plus x squared over 25 equals 1. Okay, and so since the 5's were the same, I know I'm in a circle. Okay, remember our circle equation is x minus h squared plus y minus k squared equals r squared, or just x squared plus y squared equals r squared if h and k don't exist, or 0. They exist, they're just 0. Okay, so we're going to be actually going for this one. Okay, and so the first thing I notice is, ooh, I have 25's on the bottom. Let's just multiply by 25 on both sides. I'm left with y squared plus x squared equals 25. Now, technically, that's not the equation because in our equation, x comes first. It doesn't really matter because it doesn't matter the way you add. So if you want to switch it, you can, but you don't have to. Alex should accept it. That is the rectangular equation. Okay, so when it asks for the rectangular equation, it wants those formulas we have been dealing with the past few lessons. Okay, the past 4 lessons. Okay, so it's asking for that, so that's what we want. All right, this one we want to graph it, okay? The key thing we gotta notice at one point is that it is on an interval, okay? So we can't just graph the circle, we gotta take the interval onto account. So I know this circle though, it's centered at the origin because there's no h or k. And what is our radius? Hopefully you should know. Okay, this is r squared, so it's really 5 squared. So my radius is going to be 5. So I just count out 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4, 5. Okay, and so those are my points. Ooh, and let's see how bad of a circle I can draw. All right, it's pretty ugly, but that is my circle, essentially. But what we need to figure out is this 0 to 2 pi mess, okay? Where is it starting, where is it stopping? Hopefully most of you remember 0 to 2 pi is how much around your unit circle. It's the whole way around. So with this topic, what most of you will notice is you're probably gonna do the entire circle because we're starting at 0 and we're gonna go all the way around to 2 pi. Now, most of you also probably notice, I don't want to calculate every single point along my unit circle. It's gonna take forever, okay? So let's pick some key ones. You always wanna pick the first and the last one, right? Okay, but you also probably wanna pick, ooh, I forgot the t value, x and y. Okay, so I'm gonna start with 0, but I'm gonna pick one in the middle. I'm gonna do pi, okay? If you wanna do pi over 2 maybe, okay? And then I'm gonna finish off with 2 pi. You could do maybe your quarter spots if you just like more points to give you more concrete. All right, so x is, gonna go way up back here. So it's -5 cosine of 0. So I'm gonna go to the cosine of 0, okay? And my cosine of 0 is 1. All right, so -5 times 1 is -5. All right, and then we got pi, okay, is going to be, I'm gonna plug in pi, so the cosine of pi is -1. So I have -5 times -1, which become a +5, okay? And 2 pi is gonna be the exact same thing, it's gonna be 1. So it'll come out this way. All right, and so let's do y, okay? The sign at 0, well, is just 0, so that's gonna become 0. And the sign at pi is still 0, so that'll be 0, and -5 will be 0 again, okay? Or sorry, 2 pi will be 0 again. All right, so we have a good start here, okay? One thing I'm starting to notice is we don't really have a good direction, okay? So -5 to 0, I'm gonna plot that point. So I do know this is where I'm starting. That's my starting point. And I'm gonna go 5 to 0, but do I go 5 to 0 this way, or do I go 5 to 0 this way? So maybe we should do a pi over 2. Okay, x and y, t. All right, so at pi over 2, my cosine value is 0. Pi over 2 cosine value is 0. And so I plug that in, and so 0 times anything is still 0. At pi over 2, sine is a +1. So sine's +1. So -5 times a +1 is -5. So we start at -5, 0, then we go to 0, -5. So that tells me right now I'm going this way. Okay, and then my next one would be at 5, 0, and then we got to finish off the circle way over here. All right, and so we'll go ahead and draw our arrows going all the way this way. Okay, and so we start and end at the same point because we are doing a full circle, 0 to 2 pi. Okay, but the hardest part is figuring out what direction you're going. And really, most of you, if you know 0 to 2 pi is a whole circle, you just need to do the first 2 points and then you have it. All right. Okay, let's go ahead and switch over to the ellipse one with the same kind of 0 to 2 pi thing. So we're going to come back to this. I'll just rewrite it though. Okay. So we got x is -4 sine of t, and y equals -2 cosine of t. All right, and so we're doing the same thing with writing it as a rectangular equation. Sine squared of t plus cosine squared of t is equal to 1. So you need to solve for sine and cosine first. Okay, and so using that first equation right now, I have x over -4 equals the sine of t. Okay, and I have y over -2 equals the cosine of t. And because these first two aren't the same, I know I'm dealing with an ellipse. And remember, ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. Okay, and the way to tell whether it's a big horizontally or vertically, whatever number's bigger, a or b, okay, comes out to be which kind of, if we're doing more this way or more this way ellipse. All right, so we're gonna go ahead and plug everything in. So sine is gonna change into x over -4, and we will square it, plus cosine will change into y over -2 squared, all right, and that equals 1. So we wanna change this to look something like that, right? Well, that's not too bad, because it will just be x squared over 16 plus y squared over 4 equals 1. And boom, we already have it. All right, so it's not too bad with the ellipse. You don't have to multiply by anything because you want the a and the b down there. All right, so we noticed that the stuff under the x is bigger, 16. So that means which way is my oval gonna be? Is it gonna be more left, right, or gonna be more up, down? Okay, your ellipse, which way is it gonna be? Okay, if stuff under the x is bigger, it's more left, right. Okay, it goes more left and right. All right, and so my center, I don't have an h or a k. Okay, so I know right now that my center is 0, 0. And we're gonna go right, 1, 2, 3, 4, and left, 1, 2, 3, 4, and up and down 2. And so this is my ellipse right now. So that's the full ellipse. Ooh, I forgot to write up here. Our interval is, again, 0 to 2 pi. Okay, so that's our ellipse, but what we need to figure out is what direction we're going, okay? And so, like we learned last time, you gotta do a t, gotta do an x, gotta do a y. Always start with your first t value 0, okay? Let's do 1 in the middle, so pi over 2, and finish off with 2 pi, so we can tell what direction we're going. All right, so we have x, our t value is 0. So right here we got -4 sine of t, all right? And I'm just gonna write this down here. So what we're doing is we're plugging each t value into this, all right? So the first one I have -4 sine of 0, okay? So using your unit circle, sine, remember, is y. Sorry, I forgot to clarify that, cosine's x. Okay, so sine is 0 at 0. So this has just become 4 times 0, which we know is 0. And then we're going to do -4 sine of pi over 2. Okay, and so I go over to pi over 2, and I have my 1. Okay, sine, the y value is 1. So I have -4 times 1, which would just come out to be -4. We go back to 2 pi. Remember, 2 pi and 0 are the same thing, so put that there. All right, and now we got to do the y value. Okay, and so we know y is equal to -2 cosine of t. So I have -2 cosine of 0. Okay, and so I will start over here. And cosine of 0, cosine's x, so my cosine at 0 is 1. So that's just -2 times 1, which would become -2. All right, and then I have -2 cosine of pi over 2. Okay, and so at pi over 2, cosine is 0. So I got -2, 0, which is just 0. And then we got -2 cosine of 2 pi. Remember, 2 pi and 0 is the same thing, so that's just going to be -2. All right, so if I'm looking at this, I want to go ahead and actually graph which piece I want. So we're going to start at the point 0, -2. So this is my starting point. And I'm going in the direction of -4, 0. So I'm going to -4, 0. So we're going this way, okay? And then I have to keep going until I get to my end point, which is right where I started, which is 0, -2. And so our ellipse goes in this direction. All right, I hope you're feeling okay with how to find directions. All right, so you always want to start and then see which way you're going, and those are the way you put your arrows. Okay, you always pick your starting point, your ending point, and some point in between that actually helps you figure out what direction you're going. All right, we got 2 more examples, and the difference between these is it's no longer 0 to 2 pi. So I want to kind of go through what it looks like when it's not just going to be the entire ellipse or circle. It's just going to be part of it. All right, so we got our 3rd example here. And x equals 3 sine of t, and y is equal to negative 3, cosine of t. And this time we're at pi over 2 less than or equal to t less than or equal to 3 pi over 2. All right, so we're in a different sort of interval this time. Okay, first things first, you always want to figure out what real equation, or not real equation, in terms of our conic sections, what equation we're dealing with. Notice I got 3 and negative 3. Same numbers, means it's going to end up being a circle, okay? And so I know that I have x over 3 equals the sine of t, and y over negative 3 equals the cosine of t. Okay, and so I have x over 3 squared plus y over negative 3 squared equals 1. So we just plug those into our Pythagorean identity. Okay, sine squared plus cosine squared equals 1. Since we are doing a circle, we know the circle's equation is x squared plus y squared equals r squared. Okay, so this becomes x squared over 9 plus y squared over 9 equals 1. So x squared plus y squared equals 9 because I multiplied by 9 on both sides. All right, and so that's your rectangular equation. So if you want to go ahead and just sketch a graph of this circle, you know your center is 0, 0, and you're going out 3 on all 4 sides. And so I'm going to just do a dash because this one's not going to be the entire circle because we're on this restriction right here. Okay, we're on pi over 2 to 3 pi over 2. Okay, so we have our t, we have our x, we have our y. So we're going to start with pi over 2. And if you're looking at your unit circle, you're starting with pi over 2 and you're going all the way down to 3 pi over 2. So I think a good one to go in between that would be probably pi. I wouldn't like you guys to pick these ones in the middle because then you're dealing with radicals and no one wants to plot those. All right, so I'm going to deal with pi, okay? And then we're going to finish off with 3 pi over 2. All right, so let's start with our x, okay? So we have x is equal to 3 sine of t. So I have 3 times the sine of pi over 2. All right, and so here's pi over 2. We want the sine of it, so the sine is my y value, so it's going to be 1. So I have 3 times 1, which we know is 3. And then we have 3 times the sine of pi. Okay, so I go all the way over to pi, and my y value is 0. So I have 3 times 0, which is 0. And then 3 sine of 3 pi over 2. Okay, which would be 3 times, and at 3 pi over 2, my sine value is a -1. So 3 times a -1 is a -3. So that's how we get our x values. Let's go ahead and do our y values next. So y is -3 cosine of t. So we got -3 times the cosine at pi over 2. So if I'm looking, my cosine at pi over 2 is 0. So I have -3 times 0, which we know is just 0. And then -3 cosine at pi. Okay, and so at pi, cosine is x, so that's -1. Okay, and -3 times -1 is just a +3. Okay, and then we finish off with -3 cosine at 3 pi over 2. Okay, and at 3 pi over 2, cosine is 0. So negative 3 times 0 is, again, 0. All right, so we have our chart filled out. We have a start, middle, and ending point, okay? And so let's go ahead and plot where we're starting. We're starting at the point 3, 0, which is right here. And then we're going to the point 0, 3, which is this point right here. And then we're ending at negative 3, 0, which is over here. So I started here, and I went this way through that point and ended here. And so you're going to just graph part of a circle with those arrows. All right, I hope you're feeling okay. I think after I've gone through 3 examples, I'm feeling pretty good. I don't think I need to do a 4th. So if you guys need another one with the ellipse on the partial, let me know. It's the same thing, right? You get your ellipse equation, graph or sketch the entire ellipse, do your start, middle, end, okay? And then just kind of do that part of the ellipse when you actually graph it. All right, hope you guys are doing good. Hope spring break went well. And this is the end of 7.5.